Everybody, my name is Sahil Khandelwal and I am a third year undergraduate student studying at Amity School of Engineering and Technology. So this is an assignment under Skyfi Lab, and what we are doing in this is we are predicting a column name price of the dataset Boston housing dataset. So as you can see in this Jupyter lab in the first cell, I'm importing some of the Python libraries, and in the next cell I am importing the dataset, complete dataset of Boston housing dataset. And here using descr.descr, I am describing the data. If you want to say it properly, you can pause the video. And till now we are having that dataset in an array form. So to have it in a data frame, we are using pd.dataFrame. And now the feature's name is now the data frame. And now we are importing the target column from the data set, and we are naming it target. And after that I am just calling max or min function to know the maximum or minimum value of the target values. And after that we are concatenating the data set df by name df is equal to pd.concat features and target, and we are using access is equal to 1 so that the target value will be concatenate horizontally. After that we are having df.describe.round. I am using round so that I'm having 2 decimal digit only. So now to know the correlation of all the attributes with the target value, we are using the Pearson correlation, and this is the code for knowing the correlation. So as you can see, the bar of LSTAT is very much higher than anybody, and CHES is very much lower than every bar. So it tells us that LSTAT is very much correlated with the target value, and CHAS is uncorrelated with the target value, which is our target value is price. And here I'm using matplotlib value, which is heat map. I'm using import cbon as sns.heatmap. The heat map also tells us the correlation and via Pearson only, but in a different way, and it is easy also. And now I'm using the independent value is LSTAT and the target as dependent value, and we are predicting the target values. So that is displaying y 0 to 5 before normalization. Now we are normalized it, and after normalization I'm displaying it. So our step 2 is of defining the error. So I'm defining the error function here, and this step 3 is splitting of data. We are splitting the data into 80 to 20%. 80% is of training set and 20% is of testing set. As you can see, the test size is equal to 0.2. And after that there is an update function to update different m and c values to find the optimized m and c value. And now the main function is gradient descent function, in which will return m and c, the optimized m and c, or we can say the value of m and c for which we are having minimum error value. And now here in this cell we are initializing some of the value, and also I am calling the function gradient descent and giving some of the arguments, all of the arguments basically. And this is just to show it in a animated way. Here you can see the animation from the starting. This red line is moving. It tells us the different combination of of m and c. Here m is slope and c is intercept. So for different values of m and c, we are having different values of red line, and the optimized red line is this, which comes after some time. It is this. Okay, so you can see it is very much correlated or very much optimized value of M and C. So after this we are displaying it with all the data. Till here we are displaying it with the test or training values, but now we are this blue scatter points are all the data points, and the red line is the value, is the line which is having M and C of the optimized M and C. So after error visualization we are plotting the error values. So here it is, these are the error values, and the y-axis contain error and the x-axis is having iterations, number of iterations we are having. So as you can see, after increasing the number of iterations, the error will decrease. Now predicting the values. So the x-test is the value of L stat and predicted is the value of prices which we have to predict. So computing the MSC for the predicted values on the testing set, mean squared error function is used here. So you can see 0.0222640 something is our M mean square error value. Now putting X test and Y test and predicting values in a single data frame so that we can see the predicted values alongside the testing set here. And now we are plotting the predicted value against the target values. So the target value is this. So the target value is this, the blue lines, and the predicted value is with red line. Okay. So the scatter point of target value are in a straight line, as you can see here. So after all this, we are revert the normalization to obtain the predicted price of the house in dollars. Okay, so reshape to change the shape that is required by the scalar. Now what I am doing is reshaping it and renormalizing it, revert the normalization to predict the pricing values. So this is to remove the extra dimensions we are having, and now zipping and unzipping the values. And now the P data frame is having all the predicted and target values.